Morning, this is Stat Sensei, Mr. Spensei, and this is going to be the wait time is killing me, or the wait is killing me, and we're talking about the ambulance and private delivery, and this will be a confidence interval, or so a two sample T confidence interval. Patients with stroke symptoms arrive at a medical center either by ambulance or by private transportation provided by themselves, family, or friends. Upon arrival, the time of arrival is recorded, as is the time diagnostic treatment begins. A researcher wants to investigate where the mean wait time for patients with stroke symptoms differs according to the mode of transportation. Should say two random samples. A random sample of 85 patients with stroke symptoms who were arrived by ambulance, and a random sample of 75 who were self delivered to the ER. For each patient, the mode of transportation and the wait time were recorded. Summary statistics for each mode of transportation are shown in the table below. All right, so we need to create a 94% confidence interval. And this is our formula, x bar 1 minus x bar 2 plus or minus t star, the square root of s1 squared over n1 plus s2 squared over n2. By the way, this part is the same as the denominator for the hypothesis test. All right? So I've recorded the information from the table here just to make order out of it, and I've drawn my picture. Now notice on the other one, we were centered at 0 because when we were looking at the hypothesis test, we're centered at 0 because we're saying mu1 minus mu2 equals 0 because that was our hypothesis. All right? Here, we're not centered on that. We're centered on the difference in the means. So we need to go subtract those real quickly and find out what they are. 7.12 minus 9.25. So we're centered on negative 2.13. Well, that's a difference between the two tests. And we're going to go ahead and run the test because we can't calculate T star yet because we don't know the degrees of freedom. There's a very fancy formula for figuring that out, but we don't need to know it for AP statistics. So we're going to go ahead and run the test and get our degrees of freedom and our interval at the same time. Also, we have two samples. So this is a two sample T interval. And it's really a two sample T interval. And if you have that, you're fine for the difference of means. That's what we're really doing, but the part two sample T interval is good. So stat, test, dropping down to way down to two sample T interval, which is at 0. As you can see, I've already put in the data, the 7.12, the 3.95, and they told us up above they wanted a 94% confidence level. I have that in there, and we never pool. So we're going to calculate, and we got a bunch of information. We're going to go ahead and write the interval down, even though we're not really ready for it. And we're going to say, well, the interval is negative 3.444, comma, negative 0.08158. This is my lower bound. This is my upper bound. All right. So we have that information, but we also have our degrees of freedom. So I'm going to mark that down up here under T star. My degrees of freedom are 144.95. DF equals 144.95. All right, so now it's going to ask, I'm going to go second vars, inverse T, and I'm going to have to, it asks for area. So that means I'm going to have to go area is 1 minus 0.94 divided by 2. So let's plug that in. Parenthesis 1 minus 0.94, close parenthesis, divided by 2, degrees of freedom, 144.95. And I end up getting a T star value of negative 1.8956. please make it positive. So T star is 1.8596. And now I can go ahead and plug into the formula. So we have 7.12 minus 9.25 plus or minus. That's what gave us this. Now we have our T star, and I'm just going to go to two decimal places, 1.85, all right? 9, I'll do 3. Standard deviation, 3.95 squared over 85 plus 4.72 squared over 75. Now, the parameters. Let mu1 equal the true population mean time for delivery by ambulance, mean wait time delivery by ambulance, and mu2 let the true population mean wait time for private transportation. All right. The conditions. Well, the conditions are the same. We have random sample, n is less than 10%, and they need to be normal by central limit theorem because in this case we know that they are because both samples are greater than 30. Didn't want to go over those again because we did them in a previous video. So there they are from the previous video in the hypothesis test. So if you want them, go to the hypothesis test video or take a picture of that. So our conclusion, well, what are we sure of? Well, we are 94% confident that the difference that the true population mean difference in wait times. And here you have to put the order that you went in. We went ambulance minus private lies within the interval. And we calculated the interval earlier. We have negative 3.444, comma, negative 0.08, negative 0.08158. Make sure that I have that right. Stat test, drop down to 0. Pool up, negative 0.858, not the 0. I put the 0 in the wrong spot. So negative 3.444 to negative 0.85, negative 0.8158. And what can we say? Well, in repeated sampling, we expect this method or our method to capture the true population difference in mean wait times, and ambulance minus private, 94% of the time. All right. So let's take a look at this real quickly. This says true population difference in mean wait times. All right. And this says mean difference in wait times. Ooh, one of these has to be wrong. Difference in means. That's what we have, the difference in means. So this one is correct. This right here would have been paired. So make sure you don't do that. So make sure that this says true population difference in mean wait times. True population difference in mean wait times. All right. Hope that helped. Hope that you understand the difference between a paired and a two sample T. And look forward to seeing you on the next one. Thank you.